Hello friends, welcome to my channel Patra Tutorial. In this video I will be discussing about another solution to critical section problem by using flag variable. Okay, so in the last video I discussed about using turn variable, right? So using turn variable we are satisfying the mutual exclusion property, but it is not satisfying the progress or bounded waiting, right? So let's and that was the wrong solution, as I already said in the last video. Okay, and this is also one wrong solution we are studying. Then we will go for the Peterson solution. Okay, so let me start. So in this mechanism, basically we will be using one flag variable, that is one array. Okay, so flag variable is nothing but one array, okay, of two elements. Okay, so initially both of the elements will be false or zero. Okay, then they will be updated or will do something. Okay, so let me take one two processes. Suppose these are the this is process p1 and this is process p2. Okay, now what they are doing is, see, this part of the code is entry section. Okay, this one, and this part of the code is called exit section after the critical section, right, as I already discussed in the last video. Okay, so what it is doing in the entry section is that it is updating the value of flag 0. So this is for process p1. Okay, this is for p1 and this is for p2, let's say. Okay, so this flag array is having two value. Okay, initially both of them are 0. Okay, or both of them are false. Okay, so first while entering the critical section, the p1 will check, or p1 will update the value of flag of 0, the first element, to 1. Okay, this one. Then it will check flag of 1. That means what? Flag of 1 is for p2, right, and flag of 0 is for p1. So this indicate that, this line indicate that that means what? P1 is saying I am interested to go to the critical section. It is declaring by making the value of flag of 0 to 1. Okay, so it will update the value of 0 to, this is 1. Okay, and now it will check while flag of 1 is equal to 1 or not. That means what? It is checking whether the second process is interested or not. If this is also interested, then it will create problem, right? But right now the value of flag of 1 is what? 0. That means what? This is not interested. So this is false, means what? It will come out of this while loop and enter into the critical section. While this condition is true, it will do nothing and it will keep rotating here only, right? Now P1 can easily enter into the critical section. Okay, and while leaving the critical section, what it is doing? Again, it is changing the flag of 0 to 0. It will again change the value up to 0 only. Okay, so this is what it is doing. So in this section, it is checking. No, in this section, first it is means announcing that I am interested to go to the critical section. Second, it is checking whether the other process is, means second process is interested or not. If that is not interested, then it will go into the critical section. Okay, then while leaving the critical section, it will update the value of flag of 0 to 0 again, false. Okay, same thing P2 is doing by using what? Second element of this flag variable. Okay, so this first element is for p1 and second element is for p2. So it will check whether first it will update the value of flag of 1 to 1. So it will update the value of this to 1. Then it will check flag of 0 is interested or not. Okay, so right now the value of flag of 0 is what? 0. So this is false, so this will go to the critical section. Okay, and it will execute the critical section. Then again, while leaving the critical section, it will update the value of flag of 1 to 0. Okay, so this will be again 0. Okay, so this is what they are doing, right? So first they are updating the they are showing the interest. Then second, they are checking whether the other one is interested or not. If it is not interested, then they are directly getting into the critical section, and while leaving the critical section, they are updating their flag variable to 0 or false again. Okay, now since we have to satisfy three conditions, first one is what? Mutual. And again, in this code, this is the critical section. This part of the code is called entry section, sorry, and this is the exit section, right? Now let me check one by one whether all three conditions are satisfying or not. Okay, so first one is what? Mutual exclusion. Okay, first one is what? Mutual exclusion. Let me check this one. Okay, now suppose initially the flag value is 0 and 0. Okay, both are false, 0 and 0. And now suppose P1 is trying to enter into the critical section, so it will check here, it will update the value of flag of 0 to 1, so it will be 1. Okay, then it will check whether flag of 1 is 1 or not, but right now the value of flag of 1, this is 0 and this is 1, right? So flag of 1 means what? This element, this is 0, so this condition is not satisfying, so it will go to the critical section. Okay, now P1 is executing in the critical section, and suppose at this point of time P2 is trying to enter into the critical section. Okay, so P2 will make a context switch here, and P2 will try to enter into the critical section. Okay, now what will happen? Now see, it will update the value of flag of 1 to 1, so this value will be updated to what? 1, and it will check while flag of 0 is equal to 1. Right now the value of flag of 0 is what? 1, right? So this condition is true, and since this condition is true, it will keep rotating here only, it will do nothing, again it will check, again it is 1, it will again do nothing, again come back to this condition. Okay, so until this flag of 0 is 1, this will be rotating here only. Okay, now suppose P1 completed its execution, and it is leaving the critical section, and it is updating the value of flag of 0 to 0, right? So it will again change the value of flag of 0 to 0, suppose this one. Okay, now see, as soon as the flag of 0 will be updated to 0, this condition will be false, right? Now P2 will enter into the critical section, right? So this indicate what? Only one process can enter into the critical section at a time. See, when the process P1 was in critical section, P2 was not able to enter into the critical section, but when P1 completed, P2 is immediately getting into the critical section. Okay, so mutual exclusion is satisfying now. So again P1 or again P2 will give the chance to P1, right? So this condition is satisfying, but again we have to check for what? Second one, that is what? Progress, right? So let me check whether progress is satisfying or not. Okay, progress means what? One process, if one process is not interested, then it will not affect the other process to get into the critical section, right? So that is what? Progress. Now we have to check, suppose P2 is not interested. Okay, so whether P1 can repeatedly enter into the critical section or not. Okay, so that is what we have to check, right? So now suppose this is my flag again. Okay, initially both are 0. Okay, and now P1 started, and P1 is checking that it will update the value of flag of 0 to 1. Okay, so this value will be updated to 1, and second line, while flag of 1 is equal to 1, so this is 0 right now. Okay, so this is not satisfying, so get into the critical section. Okay, then execute in the critical section. Okay, now suppose P1 completed its execution in critical section, then it will come out of the critical section and update the value of flag of 0 to what? 0 again. So it was 1, but now again it will be updated to 0. Okay, suppose these are index, and again it is updated to 0. Okay, now and by executing remainder section, P1 completed, and finally P1 completed its execution. Okay, now one round completed, and P1 successfully completed its execution. Okay, and now suppose P2 is not interested at all to get into the critical section. Now again P1 is trying to get into the critical section, whether it can go into the critical section or not, that is what we have to check. Okay, now see, again P1 will start here, right? Again it will update the value of flag of 0 to 1, so again this value will be updated to what? 1. Okay, and second line, while flag of 1 is equal to 1, but it is 0 only, right? So this condition is not satisfying again, so again it will go to the critical section. See, now P1 is again for the second time getting into the critical section. Even if the P2 is not interested, there is no problem to enter into the critical section for P1. So as many numbers of times P1 will try to enter into the critical section, it can go there. Okay, so there is no problem at all in this case. Okay, so again it will update the value of flag to 0, and again it will come out from the critical section, again it can enter into the critical section. Okay, so there is no restriction in how many times P1 can enter into the critical section. So that is what progress is, right? So only the process which are interested to get into the critical section, they will be competing for each other, not the means process which are not interested. Okay, and the competing process should not be affected by the other processes which are not interested to get into the critical section. That is what progress. So in this case, two conditions are satisfying, right? Mutual exclusion and progress, and bounded waiting is optional, right? So that is not the major issue here. But now look at another problem here. Suppose, and since we know that the process can make context switch at any point of time. Okay, that means what? Any process can preempt any other process from the CPU at any point of time. Okay, now suppose P1 is executing, P1 started execution. Okay, suppose P1 initially, let me write here. Okay, so suppose initially flag equal to, flag is 0 0 again, flag first one is 0, second one is also 0, this is the 0th index, this is the first index. Okay, now P1 started its execution. Okay, so it executed first line, so flag of 0 equal to 1, it is changing the value of 0 to 1, and at this point of time, suppose at this point of time here in this line, after first line completed, P1 make a context switch, and no, P2 will try to enter into the critical section. Okay, so at this point of time here, then what will happen? This will stop execution and P2 will start execution. Then again it will change the value of flag of 1 to 1. Now see, it is changing the value of flag of this one to 1. Okay, flag of 1 means what? Second element, this one, right? So P1 stopped here after executing the first line, and P2 started, and it is successfully executed the first line and updated the value of flag of 1 to 1, and now it is trying to execute the next line. That is, this is what? While block. Okay, so what it is doing here, flag of 1 is equal to 1. Yes, flag of 1 is also 1 and flag of 0 is also 1, right? So this process P2 will keep rotating here only, and process P1 will keep rotating here only. Okay, so neither P1 nor P2 can enter into the critical section. See, in this case what will happen? It will go to the deadlock state, means they will be they will be in waiting state only. P2 is waiting for P1 and P1 is waiting for P2, right? So it will be very long waiting, or what it will be enter into the deadlock state. Okay, that is called deadlock. Okay, so this is not the progress, right? Means to achieve the progress, we are there is a chance of chance that our system may enter into the deadlock state. Okay, so this is why this is also not the correct solution for critical section problem. Okay, so first we studied by using turn variable, and this is by using flag variable. So this is also not satisfying the progress properly. So in the next video I will be discussing one more solution, that is called Peterson solution, and that will satisfy both mutual exclusion, progress, and also that last one. Okay, so we will stop it here only, and thanks for watching, and thanks for your support.